We know that more than 100 different elements exist on Earth, but how would we sort them? Suppose you have 4 different types of food: fried rice, cream cake, grapes, and coffee. We can separate these into different categories according to their taste and/or sources. These 4 foods can be sorted as savory, sweet, bitter, and tangy in taste. If we categorize them by type, we could separate them into meat and grain, dairy and sugar, and fruits. So it is possible to separate large groups of items into smaller categories according to the common properties that they share. In this video, we're going to look at how scientists categorize elements of the periodic table using their properties. You will learn about subshells and their types, and how the periodic table is divided into 4 different blocks: S, P, D, and F. Electrons are divided into different atomic shells: K, L, M, N, O, P, and Q. The K shell of an atom is the first shell and is closest to the nucleus. It can hold a maximum of 2 electrons. The second shell, L, can hold 8 electrons, and the third shell, M, can hold 18 electrons. The N shell is even further away from the nucleus and can hold up to 32 electrons. Elements have been sorted into periods depending on the number of shells each element possesses, and into groups based on the number of electrons in the outermost shell, also known as valence electrons. However, scientists have further classified the elements into different blocks: S, P, D, and F. They realized that each atomic shell can be further divided into subshells or orbitals. There are 4 different types of subshells: S, P, D, and F. S subshells can only hold 2 electrons. P subshells can hold 6 electrons. D subshells can hold 10, and F subshells can hold 14 electrons at the most. So what is the relationship between shells and subshells? How are they connected? Well, all shells have subshells. The K shell only has an S subshell, which can hold no more than 2 electrons. The L shell has 2 subshells, S and P, which is why it can hold 8 electrons, 2 electrons in S and 6 electrons in P. An M shell has 3 subshells, S, P, and D, ideo and think. 2 electrons in the S subshell, 6 in the P subshell, and 10 electrons in the D subshell. Did you get it right? Well done. So, how is this used to organize the periodic table? The periodic table is divided into 4 different blocks: the S block, the P block, the D block, and the F block. Do the letters sound familiar? Yes, these blocks are named after subshells. Every element has valence electrons located in one of the subshells. If the valence electrons of an element are in the S subshell, such as hydrogen, lithium, or calcium, they are placed in the S block. If an element has valence electrons in a D subshell, such as iron, copper, or nickel, it is placed in the D block. In this way, scientists could categorize all the elements that gave the periodic table its shape. Once all the elements were organized into groups, periods, and subshells, scientists noticed an interesting pattern. Elements within the same period have the same number of shells as each other, but their atomic numbers increase as we move towards the right. Similarly, elements in a group have the same number of valence electrons, but their number of atomic shells increases down the group. This interesting pattern made them understand why elements in the same group have similar chemical properties and different physical properties. For example, since Na, sodium, and Li, lithium, have only one valence electron, they're in group 1. Their chemical reactivity is similar, but because sodium is bigger in size than lithium, they have different melting and boiling points. So let's summarize what we have learned so far. Atomic shells are divided into subshells, also known as orbitals. There are 4 different types of subshells, S, P, D, and F. Each of them has a different capacity for electrons. The K shell only has an S subshell. The L shell has both S and P subshells, and the M shell has S, P, and D subshells. Elements are placed in their respective blocks according to the subshells that contain their valence electrons. For example, elements in the S block have valence electrons in their S subshell.